All right, sorry about that. We have light energy, and as light energy hits this, we have an electron here move up to a higher energy level. Okay, so energy is absorbed. That's important to understand. It will move up to a higher position. I'll mark that in red because this is its excited state. This is the same electron. It's just moved to an excited state very temporarily. And then now here's the key part. When this moves back down to a lower energy level, because it just stays there for a little bit, moves back down, it releases energy. So now energy is released and it comes out to the universe. Well, what is that energy released? It's released as light. So let's talk about that. When it goes from excited to ground, energy definitely is released, and a bright line spectrum occurs. And this is the most beautiful thing, I think. It's one of my favorite things to watch in chemistry. It produces beautiful light. All right. So these dark line spectrums, you can see, have light frequencies that are missing because the hydrogen atoms are absorbing. These dark lines represent light that's being absorbed. So it's being absorbed right out of the spectrum. And why do they do that? Well, electrons prefer frequencies of a certain level to get just the right enough energy or quanta of energy to move up to another energy level. It needs a very specific amount of energy, and only light along that frequency in the dark lines will do that. Now, when they release it, we get these bright lines. So if we had a dark universe, we'd get these bright lines emitted whenever an atom releases that energy. And they show specific wavelengths of light being emitted out of the atom. So on a high energy source like the sun, you'll see constant emission of certain lengths based on the atoms present within the sun. Now there's something called a Balmer series. It's when electrons falling from an excited state I'm sure you can guess, down to the second energy level. And they give off visible light, which is the kind of light we like to see. It gives off a bright line spectrum. A spectrum is a collection of light on a certain frequency. And again, it gives us a visible light spectrum. So both of those are the same ideas. There we go. Different elements produces different colors of light. So because we can't look at substances and say, what are you made of? We can use spectra, we call it, to find out what is found. One of the coolest ways to find it is, I had a friend who has a problem with her jacuzzi. It's turned green, the water is green, and the first guess for most people is there's probably copper in it. Copper also gives off a blue-green color when it's mixed in water, but it also does it when it's in flame. It's sort of cool. These spectra, remember, are all unique for each element, just like a human fingerprint is each for each person. And we use spectral lines to identify different elements. Okay, let's take a look at these questions and hopefully you're okay with it. Which of the following is a ground state configuration? All right, 2, 7, nope, has a 7 in the middle, has a 7 in the middle, has a 6 in the middle. For the second energy, only this one has a ground ring. How about an excited state? 8, 8, 8. This must be an excited state. All right. For one possible of an excited state for oxygen, well, we have to just look up oxygen and know that its normal level is 2-6. And so for an excited state could be 2-5-1. Or you could have 1-6-1. Those electrons just have to move away from a lower level to a higher level. You can even have 2-4-2. And it goes on. There's no wrong answer as long as you have the appropriate number of electrons. When atoms of an element in the ground state absorb through energy, some of the electrons may do what? Well, so if it went from a ground state and it absorbed energy, it should be able to fall back to the ground state and give off energy in the form of light. All right? When excited electrons lose enough energy, they will, again, fall back to the ground. Oh, wait. No. This one is fall back to the... So when excited electrons lose enough energy, I have to be careful here. Let's go back to this one. When atoms of an element in the ground state absorb enough energy, some of the electrons... Okay, this is absorbing. My bad. When you're absorbing energy, you jump to an excited state. Hopefully someone got that before I got it. Anyway, a dark line spectrum, congratulations if you did. A dark line spectrum is produced. Now remember, this is when you're absorbing light because it takes away a wavelength. So we're looking for a keyword absorbing energy. And when you absorb energy, you jump to an excited state. So it's option C. And that, I believe, concludes, nope, we got two more. A bright line spectrum is when electrons emit energy by falling back to the ground state. And based on what we know of spectra produced by these four gases, this is really interesting, which are present in the unknown mixture. Well, we have to look at this one. Here's our unknown mixture and match up the lines. You'll see a match for this line only exists here. So we know gas A exists. And then I just look through the next unknown mixture and see if this one has a match. This one has a match. And so because these two match, I know gas D is there as well. And that's actually the only two gases we know for sure. All right, and I believe that concludes the lesson. We have that. These are all the things we've learned, and we are going to, of course, review for quite a couple days and then have a test next week. Thanks.